Welcome to the NYC Angular Meetup. This talk is from AngularJS to Angular, the seamless approach to upgrading your web app. So a quick introduction. My name is Tsai, and I've been working at Grubhub for about 4 years now, which I know in tech years is a lifetime, but it's been a fun ride. It's continuing to be a fun ride. I originally started off as a front-end web developer, but as the business needs grew, I took on a full-stack role and now own several microservices, such as geocoder, order history, order status, and session storage. In addition to this, I'm currently leading the web core team, where our primary focus is on performance, code consistency, and tooling for the developer team. At the end of the day, our job is to make the developer's job easier. I think it's also important to stay active in the different technologies today, so I've also developed a few personal web apps in React.js and in Vue. And finally, I have professional experience with JavaScript, Python, and Java. You can follow me here at Tsaibot or on GitHub at EricTsai6. So what is Grubhub? For those that don't know, Grubhub is a food delivery platform that has over 80,000 restaurants and serves 14 million active diners. The idea is to empower the diners so that they have the ability to choose from a multitude of restaurants in their area and to provide accurate ordering information and secure transactions. No more yelling your credit card number over the phone or having the restaurant mishear you when you say no nuts and the other guy hears mo nuts. We also have many brands that we maintain, which include Seamless, E24, All Menus, and Menu Pages. Most people don't realize that Grubhub is not just the consumer web app. There's also two different facets of the business that are just as important. I like to think of it as DDR, diners, drivers, and restaurants. The diner app is what you see screenshotted above, and it's hopefully what you guys are using every single day. The delivery, iOS, and Android apps were created to help dispatch our vast network of delivery drivers so that they know where and when to pick up and deliver your orders. And restaurant tablets and web apps help the restaurants manage their large volume of orders that come in every single day. And I'm happy to say that we're still hiring for all three facets. So if you want to apply, please go to careers.grubhub.com or come talk to us after the event is over. So a little bit of history where it all began. In late 2013, Grubhub and Seamless had merged together. Two competitive rivals were now one, with the same goal of creating the best product for the diners and the restaurants. Both Grubhub and Seamless at this time had large monolithic apps in Java and .NET respectively. Obviously, it didn't make sense to maintain two different stacks, so a large initiative was pushed to get everything under one stack, and that included the web application. At around this time, one of the Seamless employees was curious about AngularJS. Now, keep in mind, this is around 2013, 2014, so AngularJS was a new kid on the block. So during a free weekend, he decided to try to recreate the Seamless web application by leveraging the Grubhub APIs. This caught the eye of his manager and eventually got escalated to the higher-ups. And it was then decided that this would be the starting point of the next generation web application. The web app that you see today when you visit www.grubhub or seamless.com has evolved over the years. There's definitely some snippets of code from 4 years ago. So let's fast forward to 2015. At this point, we're now serving both brands off of the same web application code. So not only has this simplified our maintenance, but it's also increased our developer velocity. But as is always the case, the web developer's job is never finished. At this point, we were feeling the growing pains with AngularJS, specifically around performance. The main issue was that the application bundle was simply too large. At that time, it was approaching 2 megabytes, which meant more time to download and more time to execute and parse through the code before anything was even rendered. And this was because we were simply bundling up the entire application. We also got complaints about lagginess. With nothing more to go on, we started profiling our application and found that the number of watchers severely impacted the performance of the application. This was especially bad on pages with a lot of ng repeats, like our menu or our search page. AngularJS is also known to be slower at initial rendering because it manipulates the DOM directly. Compared to newer Vue libraries like React or Vue, which leverage their own virtual DOM or just virtual DOM in general. There are ways to mitigate this by using trackby, but that still doesn't address the first initial render issue. And finally, because we were leveraging two-way binding, we were encountering certain race conditions here and there because a change wasn't necessarily being propagated in the same digest cycle that we expected it to. For those that don't know, AngularJS is known to do dirty checking. So that means it's going to continually run digest cycles until all the changes have stabilized, which results in many wasted cycles. It could also mean that a change you may expect in the parent that gets triggered by the child doesn't necessarily happen in the same digest cycle. So at this time, we were trying to squeeze as much performance out of our AngularJS app as possible. So let's go through that list again. The first problem was the large JS bundles file sizes. What we did to address this was break our application into separate sub-apps. So this meant maintaining different index HTML files, but we segmented it into a user flow that made sense. So we would have a sub-app for restaurant, sub-app for checkout, sub-app for account. And this meant we could only load in the JavaScript files that were necessary for that particular sub-app. In addition to this, we also audited and removed any large libraries, like Moment.js with time zone information. At that time, it was probably approaching 50 kilobytes gzipped. So we ended up just rewriting it ourselves. To address the lagginess issue, first off, we started to one-time bind many values that we knew wouldn't change after the first initial load. This reduced the amount of watchers and made the app more responsive. We also introduced a different rendering library called Hyperscript, which cut down our rendering time on the menu page from over 1,000 milliseconds down to 400 milliseconds. This was a huge reduction, but it made our developers' lives a little more difficult because they had to know how to write HTML and how to write Hyperscript code. And finally, to address the race conditions, we started to rewrite our application to follow the one-way data flow pattern that React is built upon. The idea behind this is that the parent component houses the state, and that state trickles down to all the child components. This makes things more predictable, and instead of relying on Angular state to eventually become consistent, you know when each component sees the change because of the on-changes lifecycle of the component. All right, so for the purposes of this talk, I created a small Reddit web application demo that leverages the Reddit APIs in order to render the Angular subreddit. And it also gives us the ability to search for it as well. I provided a link if you want to go ahead and take a look at it. This small AngularJS web app is written in TypeScript, and the bundler is Webpack 1. And we've taken bits and pieces of Todd Moto and John Papa, not Papa John, John Papa style guides and applied them to our own code base and to this one as well. So let's take a quick break and look at the search component input real quick. So this is an AngularJS TypeScript component. So you can see here we're importing our own custom events manager and a model called search query. At the very top, we're exporting the component bindings where we define the template and the bindings in the controller. And right below, we finally have the controller where we house like the business logic, and you can see the component life cycles here. So I'm going to be referencing this throughout the application, but just for a little fun, why don't we change the query text to something that you guys recommend? Any suggestions? AngularNYC. All right, so what this is going to do is, let me log in real quick. So it set the query text initially to AngularNYC. And hopefully by the end of this talk, we're going to upgrade this AngularJS application to an Angular 5 app. So before we start converting our code to Angular 5, let's talk a little bit about the preparation that we had to do. So one of the first things we had to do was convert our ES5 code to TypeScript. And the main reason that we did this was because Angular and all of their code examples are written in TypeScript. And we wanted our developers to have a good time writing the application code and not worry about doing mental context switches. TypeScript also has the benefit of beyond just following what the Angular team is doing. As you could probably tell from its name, it gives your JavaScript type definitions so that you can capture possible errors before they get merged in. In the example below, you can see a small function that expects a number. Calling a function with a string will throw a compiler error, which is shown with the little red squiggly over on line 5. You're probably saying to yourself, well, of course I would never make that mistake. I'm an elite programmer. But as your team grows, you can't always look at every single pull request. And especially if you have outside contractors or junior developers, it helps to just keep everybody honest. The nice thing about TypeScript is it's also completely optional. So if you don't choose to give typings to things, it'll still compile with TypeScript instead of other preprocessors like maybe like CoffeeScript. This made the transition even easier as we could pretty much just convert the file extensions from .js to .ts and have it compile fine with the TypeScript compiler. Then as we got more comfortable, we started introducing more and more typings to the project and standardize our coding practices. I just want to give a short shout out to the TypeScript tooling, which has improved dramatically over the years. Back when we first started doing TypeScript, you actually had to do a separate import statement just to get the type definitions. Does anybody remember the / and then import.ts? Yeah, that wasn't that fun. And you also were forced to do relative imports too. So if you ever move things around, then you'd have to like find and replace all the crazy directory madness. I also want to give a couple shout outs to TSLint. So it's pluggable rules for enforcing certain coding standards. And it's also really easy to create your own custom rules. So for example, we have pretty simple ones where we reject anything that has fit or fdescribe for your unit test. We've also added plugins to reject things such as using a global window or document. And Angular language services. This is an Angular specific tool, but I thought it was worth mention. It has the ability to capture errors in your template before you even attempt AOT. And when using TypeScript, you need to be diligent about not using any as little as possible. If you're using any, then you may as well just be writing regular JavaScript because the TypeScript compiler won't be able to capture anything. So part 2 is kind of a simple one. Since AngularJS 5, components have replaced directives and become the standard way for creating these custom reusable widgets, as I'd like to call them. With it comes a much simpler interface though. So instead of the link compile, which then has a pre and then post, all you have is onInit, onChange, onDestroy, and postLink. Now, I'm sure there's a few others, but these are the main ones that we used. You can ignore that. So with the introduction of components, we also started to think of everything as a component as well. So no longer was our router just referencing a separate controller in a view. It was instead rather pointing to a parent component instead. We also did our best to house the application state inside of this parent component and have that state trickle down, like mentioned before, in order to follow a one-way data flow architecture. So part 3. Sure, I'm not alone when I say that our application relies on broadcast, emit, and $on. And I feel like there's some kind of negative stigma to that. It's like we're using jQuery or something. It'd be nice to say that we've converted everything to follow that one-way data flow pattern, and that this feature wasn't really necessary, but we live in the real world, and we need to balance our developer needs and the business needs as well. Well, in Angular, that feature is no longer available, so in order to get around that, we've created our own event manager implementation. So I showed a sample of the interface over here. If you want to see the source code, feel free to read my blog post, which is coming out soon. So on the screen, you can see that we have a simple publish and subscribe function, and it'll take in a custom event. What you may not see is that there's no ability to do broadcast and emits, and that's done on purpose. In AngularJS, the best practice is that they recommend that you subscribe and broadcast on root scope. That way that event doesn't have to travel through all the different levels of your application. This ends up being a lot more performant, and yeah, if your code is already structured in such a way, then you can pretty much use our events manager implementation and use it in production today. So with Grubhub being an e-commerce platform, we did a lot of A/B testing in order to help guide product decision. And one AngularJS feature we used a lot is the ability to choose which template to load in via an attribute. And this is particularly useful if, say, we want to test a new restaurant card. We could have a restaurant card control HTML and a restaurant card experiment HTML. And using the attribute, as you can see in the screenshot, you can load in the different HTML that way. And this is a lot easier to manage instead of having a single HTML file and then a ton of ngIfs in it, making it super difficult to follow. So ultimately, when you're done with the experiment, you can either, you can simply delete one of the templates, whether it be the control or the experiment, and move on with your life. But alas, this is not part of Angular 2, so there are a couple options that you can go with. You can create an ng switch, which requires a parent div around both of the template files. This may not necessarily be the option for you if your CSS is reliant on the DOM structure. Or you can create a base class that houses all the business logic, and then have your separate component classes extend off of that base class, and then have those two separate components reference their template files accordingly. And finally, I wanted to give a little bit of love to Protractor. This change is relatively simple, but extremely important because we relied on Protractor to give us the confidence that our application was ready to go. So in total, we have about 300 plus automation tests that test everything from the happy path to various edge cases with crazy time zone IDs and restaurants that are blacked out. And it just helps in general with our release process because we don't have to manually verify all these different scenarios. In Angular, we can no longer reference, in Protractor, we can no longer reference our Angular app with by model, by repeater, or by binder. You'll have to use by CSS instead. Which sounds simple enough, but how do you really make it resilient? What if you wanted to uglify your CSS? Or someone's optimizing the CSS selectors and sees that menu item class isn't in the style sheet. This makes your automation test really brittle. So what we did instead was we introduced an attribute to the element instead with a prefix of AT-. This made it clear to the other developers that, hey, don't touch this unless you're really sure of what you're doing. And anybody that's optimizing the CSS won't break the automation test. All right, so by doing the aforementioned 5 high-level changes, this set us up to automate as much as possible. Since our source code was consistent, we were able to create a script that could automatically convert our code for us. To give you a better idea of the scale of this, our code base is roughly 500,000 lines of code. So why did we go with this approach? 500 lines of code is a lot, but we also wanted to minimize any kind of human error. If we had our developers switch out the $sign on init for ng on init and handle the proper imports, there were bound to be mistakes happening. This also freed up the developer time to instead look at the component's responsibilities and perhaps refactor it to make it simpler. This didn't happen that often, but as it was scary enough upgrading an entire application, but it did happen. So how did we do this? Like I mentioned before, TypeScript tooling has improved much over the years, and that includes the TypeScript library itself. We were able to utilize the abstract syntax tree to modify and remove code as needed. So what is the abstract syntax tree? It's kind of what it sounds like. It's a tree representation of your code. And I have a little screenshot there on the side. I could probably tell you how you can properly identify what each line is or each variable, but it's probably easier if I just go ahead and show you. So I provided a link. So this is, again, that search input component that I was referencing before. Let's take a look at the search input controller. So you can see that it's defined over here. And then if we want to perhaps look at the different members of this particular class, we have the ability to look at this members array and see that this is a property declaration, this is the constructor, and these are the different methods that exist on the class itself. Okay, so that's pretty cool, but I bet you're now thinking to yourself, gee, this sounds like a lot of work to rebuild everything using this abstract syntax tree. Well, you're right. If you try to do everything with AST, you're probably going to have a bad time. So let's take a look at the example that I have on the right-hand side. All I'm doing is declaring that Eric is a new programmer in order to recreate that line, I have to define a declaration list, a declarations array with an identifier text, and an initializer expression. And that's just a simple example. And I'm leaving out a whole bunch of other fields. That's why you have to balance between doing things with the AST and the regex, and with regex replacements. Using the tree, we can easily identify and find import statements, properties, methods, classes, etc. And with regex, you can find and replace pretty much everything else. And what helps this even more is if you normalize it and prettify your source code, small things like white spaces are all standardized, so there's less variation to deal with. So I bet you're all wondering what this meta programming kind of looks like. So here we have a sample of what a process component looks like. From high level, you can see that we're first loading in the file and getting the abstract syntax tree. Now I've highlighted this section and pointed it to the right-hand side. And you can see that we're using the TypeScript library itself to generate this AST. The next line, we then normalize it as much as possible by making sure that the import statements are first, then any possible variables, and then interfaces, then enums, and then so on. And then we regenerate another abstract syntax tree based off of that normalized string that we've created. Now I want to draw your attention to this other function called remove from constructor, as it's easier to follow. So you can see that we're passing it the AST, and then also an array of parameters that are no longer supported in Angular. By the way, if you didn't know, $Q, $timeout, $interval, and $route params are not supported. So what this does is it takes a look at the AST, it finds the class declarations, it finds the constructor, and then looks at the parameters of that constructor and tries to map that against the array of parameters that gets passed in. If it finds that it's a match, it removes them. And if it finds if it's not a match, simply keeps them. What we do afterwards is we then convert it to a string representation of our code at the line below. We run it through a prettifier, and then we do some regex replacements on the source code itself. Finally, when this is all said and done, we write this to a temporary file. Yeah, and then we just write it to a temporary file. All right, so what could go wrong? Live coding. What we're going to do is attempt to upgrade this AngularJS application, run it through the conversion script, and see this Angular 5 application out in the wild. Okay, so the first thing I'm going to do is I'm going to cheat a little bit. I'm going to give it the app module, app routes, and some config files because we simply didn't automate that. We manually updated that ourselves. And here I have an upgrade folder that is essentially a cloned repo of an Angular starter project itself. I'm going to paste this into source.app. So all we have is app module, app CSS config, what have you. Now we're going to run our script and update all the components. And this will be instantaneous. There we go. We're going to update the template files. Update the models. Services, utility, and then finally we simply just need to, what I call yank, move over the SAS files. All right, so now let's go to our upgrade folder and run npm start. And while that's running, I can show you what's happening in that upgrade app folder now. So as you know, I've moved over all the components, all the utility services, and what have you. And let's go back to that. Oh, ignore that. Let's go back to that input component. So it's taken everything that we had in our AngularJS code and simply converted it, making it ready for Angular 2. And the query text that we originally set with AngularNYC is still being retained here as well. So now if we go to this application, the Reddit logo 404s, but you pretty much have a functioning Angular 5 application. And to prove I'm not cheating, here we have an app and with the NG version 5.1.3, which is how Angular tags its applications. So the purpose of this slide is not to show up, but to give you an idea of how much time an upgrade like this can take. Though I do think it's pretty cool that this was achieved by a relatively small front-end web team. Please note that your mileage may vary. At the time of our upgrade, we had 8 engineers all working together on the effort to convert our AngularJS application, which was about 500,000 lines of code. And the conversion is really not that bad. We first upgraded to Angular 4, because Angular 5 just came out, what, like 2 or 3 weeks ago? But that demo did Angular 5. Thank you.